Okay, so I know there's a number of you that are having some problems accessing and doing this earthquake gizmo correctly. So I just wanted to go through a few parts of it to help you um, get a better understanding of what you need to do. So the first thing, you need to open up two different things. This is the worksheet that will allow you to do the exercises. They have all the directions on it and the questions. So we're going to open up that. And then we're also going to go down here to where it says click here to enter the gizmo. So I'm going to open this up, download that. So here is the worksheet. The other thing that needs to be opened is the gizmo itself. So I'm going to open that as well. So you're going to click on that and then click on go. Sorry, that's a little bit outside of the recording window. So this is going to load, and we're going to have to toggle back and forth between um, the, the worksheet and the gizmo itself. So I'm going to go back to that for a minute. So the first thing it asks, these first questions really are, what do you know about earthquakes so far, is really what this is asking. And so those are going to just put down what you know at this point, and then we're going to go on and we're going to get started. So I think this first page is pretty self-explanatory. So it says on the warm-up, the recording station gizmo simulates seismic waves released by an earthquake. To begin, look at the key on the bottom left side of the gizmo. Okay, so if we just go back to that really quickly, the bottom left side, I can expand this window just a little bit. Okay, so you have two different keys here. The triangular area is identifying where the actual station is, and then this little circle with the plus sign is where the earthquake is. So that's what those two questions are asking on A and B. And then it says click play, observe the seismic waves leaving the epicenter of the earthquake. So if we go back and click play right here, and we have both P and S waves that are being produced. Okay, and as you can see, that's operating. Then we have this little thing over here on the side that shows you actually what that seismograph recording would look like. So let's go back again to the worksheet, and I'm going to scroll to the next page. Now, I tried to highlight on here to remind you that every time you do this, you need to reset before you start. So it says get the gizmo ready, click reset, check that the distance from the station to the center of the earthquake is 860 kilometers. So we'll go back, we're going to hit reset. And then we have to drag this if it doesn't say 860. So here's your distance right down here on the lower left side, distance from the station to the center of the earthquake, 860 kilometers. So we're good. Go back to the worksheet. The next thing it says to do, an earthquake releases an enormous amount of energy which passes through the Earth's interior in the form of body waves. There are two types, P waves, also known as primary waves, and S waves, which are also called secondary waves. So how are the P and S waves shown on the seismogram? It says to click play and then pause after the purple P wave hits the station. So I'm going to go back. I'm going to hit play. So those PNS waves are going to shoot out from this where the earthquake is in the lower right of this map. And then over here on the left-hand side, a little bit high or north of center, is where the station is. So we're going to play that until the purple ring hits that station. So we're going to go and stop right there. Okay. Now, so the question asked, go back, look at the right corner. At what time did the P wave hit? So we are going to go up here on the P wave, and we look at these. Right now, the time is 1:52. So that's what we're going to put down for an answer. I'll type that in. 152 seconds. what is shown on the seismogram at this time. So if you look back at the seismogram itself, you just see a fairly straight line, just slightly squiggly. Okay, so that's what you can write there. Then the next thing that it's asking is we're going to hit the play after the green S wave hits. So we're going to play, and then I'm going to hit pause again right there. And so now you can see that the time is 2:54. Okay, at what time did the S wave hit? At 2:54 seconds. What is shown on the seismograph at this time? So if we look again, now you can see that it's a little bit more squiggly than it was before. So if we hit a play for just a little bit more, you can see that it bounces up. Okay, so we have this really squiggly line, which is representing the movement of the P wave, and then we have this really more dramatic, uh, bigger jumps with the pen when the S wave hits. All right, so we're going to move on. Click play and wait for the vibrations to stop. Suppose you were at the recording station when the earthquake hit. Based on the pattern of waves, what would you experience during an earthquake? So what do you think you would see with those kind of waves that are shaking the ground? Okay, so we are going to move on to part B. And this is where I am seeing the majority of the problems. So again, it says get the gizmo ready, click reset. This time, make sure that your recording station is at 300 kilometers. And so once we've done that, we're going to hit play and then observe the PNS waves. So go back to the gizmo, reset, and then I need to grab onto this and I'm going to watch down here and I'm going to move this until I'm as close to 300 as I can get. 298 is pretty good, so I'm going to go ahead and do that. So I'm going to click this and I'm going to play it all the way through. Just PNS waves. Okay, so now that that's gone all the way through, if we go back, there's a couple of questions. Which waves are faster? You should have observed that the P waves, the purple ones, the P wave travels faster. Okay, now measure the time that how much longer it takes for the S wave. Instead, it's a turn on show time probe. Place the green probe on the first P wave. So that's going to be our first little blip. And then the right or the blue probe on the S wave. And there's an example right here, but this is where people were running into trouble. And so I would like to just quickly show you that. So first of all, we're going to click this, turn on that probe, and we're going to grab this one, the green one, and we're going to move it to where we see that first little movement of the P wave. And then we're going to take the blue one. This represents the S wave. And this is where we see that first really big jump right about here. Okay. I'm just moving it. So now we can see it says the time difference. So the P wave arrived at 54 seconds. The S wave arrived at 75. So we have a difference in 21 seconds. And so that's what that question is asking right here. So what is the time difference? 21 seconds. Okay, now predict what you think. What do you think the time difference between the PNS waves will change as the distance from the epicenter increases? So the farther away the station is from the epicenter, what do you think is going to happen to this triangle T? It's delta T, the change in time or difference in time. And so you're going to make a prediction here. I think that, tell me what you think. Now, what you're going to do is you're going to fill in this table. And you need to fill in this table because you need to create a graph. So you are going to put your recording station at these different distances. So we'll go back. Remember to hit reset. And then we're going to go, the first one was 100 kilometers away. So I'm going to drag it till I get to 100. as close to 100 as, and it's not, if you don't get it exactly at 100, it's not the end of the world. So I've got it at 98. So what I'm going to do is I'm going to hit play, and you can take these off for now if you'd like. Play. And we are going to just let that run till it's over. And then we need to put those little measure things on again. And so remember, this green one is for the P wave. And so we have to put this where the very first, this is going to hit pretty quickly. And then we're going to put the S wave to where we get that first jump. And then we're going to look down here, our difference in time, 13 seconds. So we're going to go to our table, type in 13, then we're going to go back. We're going to do the same exact thing, except now we have to hit reset. We're going to put this at 200. I'm going to go 197. So I'm going to turn this off again. Let it go. So again, you can see where that and then we can use the probes again. So this is where our S wave ended up. This is where our P wave is. For the most part, you can leave the P wave pretty close to the center. It really is kind of sometimes a little bit more difficult to see those, but we're going to go with the difference of time of 29 seconds. So I'm going to go back, put this one in here, 29 seconds. And then what you need to do is you're going to go through and you're going to do that for each of these distances, 400, 600, 800, and 1,000. And when you're finished, you're going to graph that data. And what I would recommend is that you just get a piece of graph paper and you do it on a piece of paper and then take a picture and upload it. But when you're finished, you should have a graph that looks like this. And this graph is going to be necessary for the next part of the assignment. So we're going to go back to the worksheet for a minute. We're pretty much done with the Gizmo for now. So we get down here, you're going to answer these other questions, but I want to just quickly go here. So it says practice on each of the seismographs below, labeled the first P wave, the first S wave. So right here, I'm going to insert a little arrow shapes, block arrow right here. Right here is where the P wave is. Okay, and then I'm going to insert shapes again, another block arrow right here. So what this is saying, if you look, it says each line represents 50 seconds. So 50, 100. The P wave arrived at 150. The S wave arrived at about 250. So our delta T, the change in time, 100 seconds. Okay. Then we need to go back to this graph, and I'm talking a little fast because my free sample is running out. So we're going to look here, and we have to go up to 100 seconds, and we're going to go across, and then we're going to drop down to determine how far away that earthquake would be. And so this line here is 600, this would be 700. We are a little bit beyond 700. We're at about 750. So I'm going to type in a distance of 750 kilometers. Okay, so hopefully that helps you out a little bit. I am going to sign off because I'm just about out of time on this particular, it only allows 15 minutes of recording and we are at about 15 minutes. And so if you still have questions, send me an email.